So, what the heck's an isosceles triangle? Don't all speak at once.
Two sides are equal.
Two sides of a triangle are equal, right? So the first thing that we want to talk about before we get to this isosceles triangle is just a triangle in whole. So draw a triangle. And if I put this angle right here and this angle right here, these angles right here are called the base angles. So basically, this is my base. And realistically, the base of a triangle could actually be any side of the triangle, but normally it's the side that it's sitting on. And then, so because we call this a base, obviously our base angles are going to be these. And usually the base angles are the congruent angles in an isosceles triangle. So then obviously we have another angle up here. And this angle at the top is called my vertex, or the vertex angle. And then wherever you find your base, the other two sides are called my legs. If you think about a right triangle, which we've talked about before, the legs would be the sides of the triangle that make up my right angle, or where the box is. But the legs of an isosceles triangle would end up being the congruent sides of an isosceles triangle. So this leads us to two theorems. And this one you got to be kind of careful because you're going from one to the other. So this is my isosceles triangle theorem. And this basically just says if two sides of a triangle are congruent, the angles opposite those sides are also congruent. And when we say opposite in this case, we're talking about the diagonal again. Okay? So, real quick, we draw any kind of triangle that we want. If two sides are congruent, they're going to show this either by putting the little slashes there or putting actual numbers there. Then the sides opposite of them are also congruent. And we kind of represented that when we showed what we were going to call them anyway. So in 410, you're given the sides. That makes the angles congruent. In theorem 411, we're going to just go in the opposite direction. So if two angles are congruent in a triangle, then the sides opposite of them are also congruent. So realistically, there are two different ones here, but I'm not going to really lie to you. If you just recognize this, I'm not going to be a real stickler, but this one would say, because I have these two angles here, then I automatically know that my sides opposite of them have to be congruent also. But what I was getting at before I stopped there, I'm not going to be entirely picky if you forget that this is 410 and this is 411. So basically, if you have the sides and you know then that the opposite angles or vice versa are congruent because of being an isosceles triangle, I'm good with that. And then the last, or there's a couple of corollaries in this one. And again, a corollary is just kind of like a rule again. So corollaries hopefully are just basically kind of obvious things again. And now we talk about a triangle is equilateral. What does it mean if it's an equilateral triangle compared to an isosceles triangle? All the sides, right? So a triangle is equilateral. Remember what IFF meant? If and only if. It is equiangular. What does it mean by equiangular? It just means that all the angles are the same, right? So if all the sides, then all the angles. And then hopefully that was pretty self-explanatory, and then hopefully 4 is even more. So again, if you really don't want to write these two down, that's not that big of a deal. But in corollary 4, we would say each angle of an equilateral triangle has to be what? Yeah, is 60 degrees. And again, hopefully that's just kind of things that are obvious. So, any questions with words? So again, this part of it should just be basic math. The ones that are still going to give us a little trouble maybe are the proofs that come with it. But we'll start out with problems that hopefully aren't going to bother us a whole lot. So here's my figure again. Now again, when they put the little slashes and the arcs on this, you have to believe it. So even if it doesn't look like it, if they put arcs or slashes on there, it is a true statement. So, don't say it out loud, let everybody have a chance to think about this. Name 2 unmarked congruent angles. Angles. Everybody got an answer? What angles have to be congruent here because of what is given? BCA and BAC. Exactly right. So we're saying that this angle right in here has to be congruent to that angle right there because of this slash and that slash. Everybody agree? So then, at the same thing, we could have said name 2 unmarked congruent sides, and we would have said what? And? What is DB going to be congruent to? CB, because why? These little arcs right here. So, in truth, what do we know about this after we went through all that? Those 2 triangles are what? Exactly the same. Because if this is congruent over here, then we can say that they're both basically the exact same thing. So again, some of these are confusing just because the figures get a little confusing. Now you got to remember, if they put this little arc here, they're only talking about angle PML. But if they come back and draw this to this, now we're talking about what? Now we're talking basically about the ginormous or the whole triangle, right? And so then we're talking about JMK and JKM. Does that make sense? So they didn't do that in this case, but that's really important that you recognize and are able to see that. Okay? So we go back and we read the question. What statement correctly names two congruent angles? And what would we say? You think D? Can this right here, is this the right three? It's the right three letters, but is it the right sequence? Because if they say PLK, I'm talking about this angle right here, right? So that's not true. B should be B, the one that I actually showed you should have been the answer, right? Because again, why? Because of my slashes here. So because we're talking about the slashes, we're going diagonal to that whole angle where I put the arcs on there. That makes sense? So again, you got to be real careful to see what are those arcs and what are those slashes pertaining to. So then we can use kind of that philosophy, and it says find the measure of angle R. So can I do that in this case? I can do that because of these being congruent. If they're the same number, that tells me that this and this have to be congruent because of 410, right? If two sides are congruent, then the opposite angles are. But realistically, this triangle is a what? What kind of triangle do I have? It's actually an equilateral triangle, so all of the angles are 60 degrees. Everybody agree with that and see why that is? Here we go. So then we can do this with algebra. So again, this is where it gets a little confusing because some people get kind of confused what they're pointing to, okay? So again, you got to just make sure that you understand that this quantity is for this angle, and then we have two sides, okay? So, how in the heck can I find x? Is it possible for me to find x? Why are they equal to each other?
Because it's, there's the two sides are congruent, so then the two angles, and they're the same.
But are the sides and the angles go together?
No, but you put 4x minus 8 equals 4x.
Well, why can you prove that? Just because of these slashes, I understand what you're saying, but see how my slashes aren't opposite of the angles? You know what I'm saying? So can I do this one for the x? Realistically, I know that this has to be what kind of a triangle? It's got to be what? Is it equal angular? The only way that I can figure out x probably is if I prove that it's equal angular. But do I know that this is equal angular? Not really, right? So can I find my y? I can find my y because the sides are definitely congruent, right? So what do I do with my quantities of y? Set them equal to each other, right? And then we just do the math. You want to see the math for the y's? So can we figure out the x's? Because if this side is congruent to this side, that means the diagonal angles should also be congruent, right? But that would be this angle right over here and this angle right here. Would you agree with that? So why do they give us this angle? Right? Maybe it was just a mistake on their part. let's see what they say. DF is congruent to FE. Yeah. Do not understand their philosophy. So this one, oh, maybe they did it this way. Maybe this is what they really wanted to do in the last one. See how they put all the slashes here? Then I'm good with that, right? So because of the having the 3 slashes, then we definitely know that this is an equilateral triangle. So then I can find my X and I can find my Y. Good with that? You want to see the math?
Either A or B.
It's either A or B.
Haven't done that yet.
B. All right, so let's look at sorry that they had a good proof in the end. Open your book to page 289, please. On page 289, we're going to look at number 7. I'll get your book here. Of course, that was the only one. Can't look at number 7 either. That's what we're going to do for the assignment. So, all right. So number 7 is on your assignment, so we can't look at that for exam grade. Basically, what we want to get to, just make sure that you read the proof carefully and draw the picture on your piece of paper, and then make sure that you put the things, meaning slashes and arcs, on your figure from whatever steps you do in your proof. Okay, so just make sure that you keep doing that. And then tomorrow, you'll get a lot of practice going back to the other versions, meaning side, 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 angle, all 4 of those that we talked about earlier. You get the whole period, you guys can help each other out. They're really not that challenging, but for some of you, it'll be a really good way to get back into just looking at kind of proofs again. Okay? And then I think we have one more section, and then we'll have a quiz, I think, Thursday. All right? And the Thursday quiz will be basically what the worksheet's going to be tomorrow, all proofs. So really concentrate. I know some of you are going to ask for help with the people that are in here. That's great. But you got to try to do some of them by yourself so you understand what you're doing on Thursday. Okay? I'm not trying to trick you or anything. So just remember to go real slow and write things down. Write things down.